This is one of my favorite topics. We're going to be working on describing number patterns today. It is always fun to figure out a pattern. I think most of you agree. Before we start on the fun math problems, I want you to look at a little bit of vocab. I'd encourage you to write this down either in your notes or make little computer note document or Quizlet flashcards for them. But some vocab that I want you to work on today. We're going to be focusing on inductive reasoning. And inductive reasoning is making conclusions based on patterns that you observe. So you see, we're going to be working on normal number patterns today. So you might see something like, 3, 5, 7, ... Okay, I wonder what's coming next. You're looking for a pattern. You see this pattern. It looks like it's adding 2 every time, or the odd numbers. And you're coming up with a conclusion of what's going to happen next. A conjecture is that conclusion that you reach by inductive reasoning. So in that pattern above 3, 5, 7, my conjecture might be, I believe that the next number would be 9. Okay, that could be a conjecture. That's the conclusion that I reach by the reasoning that I'm using. A sequence is just a number pattern. Okay, some sort of pattern of numbers, a sequence. A 3, 5, 7, that's a number sequence. Term is each number in a sequence is called a term. So if I say, what's the third term in my original pattern that I just put up there, you would say 7. 7's the third term. So each different number in the sequence is called a term. And then this is the big one that we're going to be focusing on today, an arithmetic sequence. That's pronounced arithmetic because in this case it's an adjective, it's not a noun. So it's an arithmetic sequence. And that is a sequence formed by adding a fixed number, a common difference to each previous term. So actually this example that I gave above is an arithmetic sequence because each time I'm adding 2. So it's an arithmetic sequence because you add the same exact number every time. Now obviously not all patterns are arithmetic sequences, but that one happened to be. All right, so what I want you to do is use inductive reasoning to describe each pattern and then see if you can figure out the next 2 numbers in the pattern. I want you to try all of these problems on your own and then come back and check with me because it's not fun for someone else to tell you the pattern. It's much more fun if you can figure it out yourself. So make sure you pause and then we'll talk. Okay, so in the first pattern it goes 1, 5, 9. I might notice this looks like it could be an arithmetic sequence because I'm adding 4 numbers each time. So my description of the pattern that I originally see is add 4 to the previous term. And if I look at that, then I'm going to think that the next 2 numbers are going to be 13 and 17. Okay, looking at B, I see 1, 3, 9. Now, one thing that I want you to notice is because I haven't given you very many terms, there might be more than one right answer, but I'm going to write down the first thing I notice. I notice that from 1 to 3, it's multiplying by 3. And then from 3 to 9, it's also multiplying by 3. And to me, it looks like it will probably continue to multiply by 3 every time. So multiply previous term by 3. Something like that for your pattern. And then it looks like my next 2 terms with that pattern will be 27 and 81. Now I fully understand some of you might have said, okay, I add 2, then I add 6, maybe I'll add 10 next time. You might have come up with something else that was a reasonable pattern just for that small amount of data. Okay, when I'm looking at this next one, this one's a little bit trickier. But I notice that these are all odd numbers, and because I've studied numbers a lot, these all are perfect squares. This first number is 1 squared, then 3 squared, then 5 squared, then 7 squared. So to me, the pattern I initially see is that you're going to square the next odd numbers or consecutive odds. So if I do that, then I think my next 2 terms I'm going to probably square 9 and square 11. So I think my next 2 terms will be 81 and 121. All right. On this slide, we're going to deal only with arithmetic sequences, so everything in here is going to have a common difference. And what I want you to do is find what that common difference is. So for this term, 5, 2, -1, -4, I'm noticing that I'm subtracting 3 also known as adding -3 each time. So my common difference equals -3. Okay, try the next one for me. 8, 11, 14, 17. Okay, shouldn't be too tough, I don't think. You should be able to notice that you're adding 3 each time, and this time it's a +3, so our common difference is 3. Okay, this is a challenge, but I really, really want you to try it before I give it away. So, can you find the 10th term of sequence A? Try really hard. I want you to see if you can come up with it. And can you find the 10th term of sequence B? All right, I bet you can do that with a little bit of effort. Now, I really wonder if you can figure out what the 100th term is of each of them and come up with a strategy. Okay, try that, and I will work out mine, but make sure you're pausing and really giving this a good effort before you look at what I have to say. Okay, so I noticed this first one was 5, 2, 1, -4. So what I'm going to notice is what I did is I did 5 plus -3 to get this one. And then I added -3 again. And then I added -3 again. And I kept adding -3 every time when I want to go to this pattern. Okay, what I want you to think about is back when you were in elementary school, you learned that when you added something a lot of times, that was the so I keep adding, whatever. That's the same as multiplying. So if I notice 1, 2, 3, 4, 5, 6, 7 here, if I added -3 7 times, that's the same thing as adding -3 times 7. Okay, I've added -21 to that original thing. But for the first time, the very first term, I didn't ever add -3. But the second time, I added 1 -3. To get to the third term, I added 2 -3s. To get to the fourth term, I added 3 -3s. Okay, so I want you to bear with me for a second. So what it looks like to me, what I'm doing is starting with 5, and I'm adding -3, not the term number of times, but the term number -1 times, n minus 1 if n is my term number. And that's what it looks like I'm doing. I'm adding -3 over and over and over again, but I don't add it the very first time. I started adding -3 the second time. So if I want to find out what the 10th term is, I think that I'm going to start with 5, and then I'm going to add -3 9 times. So I'm going to do 5 plus -27, and I should get -22. I don't know if you came up with that or not, but if you did, that is awesome. To get to the 100th term, I'm starting with 5, and I'm adding -3 again, but this time I'm adding -3 99 times. Because to get to the 100th term, I've moved 99 times. Okay, times 99. And so that's going to be 5 plus -297. So I think the 100th term in this case is -292. And if you got that right, again, I would be very proud of you. And let me just kind of go back and see if you got the other answers right for the other term. But this one, B, 8, 11, 14, 17. So if I'm looking at that, 8, 11, 14, 17, this time I'm adding 3 every time. So if I get to the 10th term, I've added 3 9 times to 8. So 8 plus 27 should be 35 was the 10th term there. And then for the 100th term, 8 plus 3 times 99. So that's going to be 297 plus 8. It would be 305. So you can check and see if you got both of those right. Here is the rule for arithmetic sequence. Okay. A of n, so A of n, this is going to be just like what we just did. Okay. A of n, that's the nth term, so like we did A of 100 and A of 10. That always equals A, the very first term, plus the term number minus 1, because you've added it 1 less than the term number of times, times the common difference. Okay, so this is your common difference. I put my common difference before the term number because of commutative property of multiplication. You can do that in a different order, but that's what it should look like. So this is the arithmetic sequence rule. If you're trying to find any term, you can use this rule. It always works because you're adding that same number every time. Okay, so if I ask you to find the first, fifth, and 10th terms of the sequence that has this rule, a of n equals 15 plus the quantity n minus 1 times 5, what I want you to look at is, okay, here's my formula. So this 15 is my first term. And I'd really like you to be able to point out the common difference too. Okay, 5 is my common difference. So it looks like my pattern is going to start at 15 and add 5 every time. So it should be like going 15, 20, 25, etc. And I just want to find the first, fifth, and 10th terms. This is just doing simple substitution. If I'm finding the first term, I don't even have to do any work because there it is. So a of 1, that's going to equal 15. The fifth term is going to be a of 5, and you could just continue your pattern, which is fine, but it's probably good practice to use the formula. So you're going to do 15 plus the quantity 5 minus 1 times 5. So we're just doing 15 plus 4 times 5, or 15 plus 20 is 35. Sorry about that. 35. And then the 10th term, a of 10, again, you can continue your pattern, but practice using the rule 15 plus 10 minus 1, which is 9, times 5. So I've got 15 plus 45 is 60. Okay. All right. So what I want you to try to do is close your notes and recite the rule for an arithmetic sequence to your partner, which could be your mom, dad, brother, sister, laptop, someone on Skype, someone on Facebook, something, and explain why it makes sense. So if you cannot do this yet, go back and watch a little bit of the video and see if you can refresh yourself a little bit. And before you come into class tomorrow, make sure you've tried that. I want to make sure you know the rule and why it makes sense. All right, have a great afternoon.